All right, hey everybody. Hope you guys have had a good week so far. We're going to go over special cases today, but I wanted to recap something from yesterday. Now, if you guys get to a point where you have something like, here, let's go with something like, remember you do your bottoms up, and let's say you get something like this. Okay. If your number doesn't become a whole number, you simplify and you still apply the bottoms up method. So in this case, 2 goes into both of these, so 3 and 2. Over here, 2 goes into both of these, 2 and 3. At this point, you now have this. Nothing else simplifies, so the bottom comes up. Okay, and that's how you can end up with a binomial expression where both of these values in here are something other than 1 when you put your factors together, all right? So remember that. We talked about that in the initial video. Most of the examples simplified to whole numbers, but if they don't, you reduce the fraction and then you move up whatever's left in the bottom. Anytime there's anything in the bottom other than 1 left over after you do your work, you have to move that term up to the top, all right? Okay, so today we're going to work on special cases. Some things you're going to notice about special cases is they come in one of 2 forms. Either it's going to have a binomial or a trinomial. Binomial means it's just going to have the 2 terms. So the first one we'll work on is something like this. All right, and this is what's called the difference of 2 squares. And the reason it's called the difference of 2 squares is there's a subtraction sign, which is the difference, and this is a perfect square, and that is a perfect square. So in order to do these, here's what you do. You take this, and you take the square root of it. So what's the square root of 4b squared? Well, that's 2b. 2b. You put 1 in each set of parentheses. Now, because this is a negative sign here, one of these is going to be positive, and the other one's going to be negative. Because you have to multiply a positive and a negative to get a negative. In this case, also notice that there's no b value, right? A is 4, b, there's no b value because there's nothing attached to just the linear variable b. So that would be 0 and negative 25. Okay, so now the last part that you do is, what's the square root of 25? Well, it's 5. And that's how you factor something that has the difference of 2 squares. All right, here, let's do another one together. Okay, in this one, I'm going to do 9x squared minus 36. So over here, we can change our numbers again. 9, 0, negative 36. Okay, is this a perfect square? Yes, it is. Is this a perfect square? Yes, it is. Do we have subtraction between the 2? We do. So this is a difference of 2 squares. The square root of 3x squared, or 9x squared, is 3x. So we put 1 here, and we put 1 here. Again, in order for this to work, it has to be a difference, has to be subtraction here. If it's subtraction, that means we multiplied a positive and a negative. So we have to have a positive and a negative. Now, what's the square root of 36? It's 6. So that's how you would factor those. Okay, let's do another one. Let's say that we've got 16x squared minus 49. Okay, in this case, A is 16, B is 0, C is negative 49. Is this a perfect square? Yes. Is this a perfect square? Yes. Is it the difference of 2 squares, meaning subtraction between the 2 terms? It is. What's the square root of 16x squared? It's 4x. So we do 1 of those in each set of parentheses. Subtraction, so that means 1 has to be positive, 1 has to be negative. What's the square root of this? Okay. And that's how you would do the difference of 2 squares, or special cases in this one. All right. Now, if you get something like this, is this a perfect square? It is. Is this a perfect square? It is. But it's not the difference of 2 squares because it's addition. So in this case, this can't be factored any more than you factoring out of 4. Okay, so what you would say is if something cannot be factored, it is said to be prime. Okay? Prime means it can't be factored. Only thing you could do with this is you could write it like this if you wanted to. Divide everything by 4. All right? So if you cannot factor something, you say that that is prime. All right? So that's the difference of two squares. Okay. There's one other form that falls under special cases. All right? And we're going to look at a couple of those right now. Here, we'll start with 4a squared plus 4a plus 1. Okay, now this one is not a difference of two squares. This is a perfect square binomial. All right, so in order for this to be possible, a and c, so 4 and 1, have to be perfect squares. Well, is 4 a perfect square? It is. Is 1 a perfect square? It is. And b, which is 4, in order for this to work, b must be divisible, oh, I hope I spelled that right, by 2. Is 4 divisible by 2? It is. So here's how you do this. What's the square root of 4a squared? It's 2a. What's the square root of 1? Positive 1. This sign matches that sign. Notice how the plus and the plus match, okay? And then you just rewrite it again. 2a times 2a is 4a squared. 2a times 1 is 2a. 2a times 1 is 2a. You put them together, you get 4a, and 1 times 1 is 1. Okay, so you can write it this way, or you may see it written like this. Okay, and that again is a perfect square trinomial. Okay, in order for this to be possible, this has to be a perfect square. This has to be a perfect square. This must be divisible by 2. All right, let's look at another one. Okay, actually I'm going to write the other one over here so you guys can kind of see the difference of these two. Let's go with 9x squared minus 24x plus 16. Is this a perfect square? It is. Is this a perfect square? It is. Is this divisible by 2? Yes. So we have a case where we can do this. All right. Square root of 9x squared is 3x. And you can put those in both if you want to. All right. Now the square root of 16 is 4. But now, what sign do we use here? 4 times 4 is 16. Right? Well, is negative 4 times negative 4 also 16? Well, it is. So in order to, whatever sign you're going to get in these, guys, always comes from right here. So in this case, we're using a negative. In this one, it was positive because the middle term, or b, was positive. So 3x minus 4 times 3x minus 4, those are the factors of that trinomial. Or you guys can also write this like 3x minus 4 squared. Okay? All right. So when you guys are doing these, factor them. Now you can still do the factors of a times c that add up to b with these. That will always work for you guys. But you're going to get two that match. And they should in this case. All right? If it's one of the special cases and it's in this form, your two binomials should be the exact same when you're done, which is why you can write them like this, okay? It's the same idea that you already know. You know if you have 5 times 5, that's equal to 5 squared, right? Because it just means something times itself. All right, so do your best on these special cases, work through them. Again, if you don't do the shortcuts, that's fine. You can do a times c that adds up to b, always. But I would encourage you to look, always when you get these. First thing you should look at is, can I divide anything out? Can I factor out a whole number first? After that, do I have one of the special cases where it's a perfect square trinomial or it's a difference of two squares? Okay? So keep doing your work. Keep emailing if you guys have questions. All right?